Hi, hello students. Welcome to the module number 2. We are going to discuss about the work and heat. Under this chapter, we are going to discuss about the content of shaft work, electric work, and other form of works. So, different form of work or other modes of work are shaft work. So, we will discuss about the one by one. Now, we will discuss about the shaft work. So, shaft work means, so if you take in an engine, the engine is connected with the a shaft rotated by the means of external force. Okay, so the engine shaft is rotated by means of external force. That force is called torque. Okay, so the shaft undergoes any angular displacement when a constant torque is applied to it. So what happens? The variable is only a angular movement, angular displacement, that is theta. So if you consider very small theta and then you integrate for that whole the shaft, then what will be the work by the shaft is W1 to 2 is equal to integration of 1 to 2 into T into d theta. So as T is, we are maintaining a constant torque and only the variable is d theta. As d theta changes, the work also changes. So it depends upon the angular displacement. Okay, next. So if you take for the further for the shaft power, so how you are going to calculate the shaft power? So that is, the power means what? At what rate the work is going to be performed, means the rate of change of work. Okay, that is what we call as power. So we are calling at rate we are talking about the work, so that it becomes a power. So the torque is equals to that is shaft power is equal to P is equal to T into d theta by dt. So d theta by dt means that is angular velocity. So the angular velocity into torque is nothing but a power. So this is about the shaft work. Now next one is electric work. So see here, the electric work according to that Coulomb's law, what happens? I is equal to dc divided by dt. Okay, dc by dt, what is that? dc by dt is according to Coulomb's law, that is, see, electrical work, that is I is equal to dc by dt. So where dc is nothing but what? The charges we are measured in terms of coulombs, that will be across the system boundary and in time, that is dt. So electrical work can be calculated by the equation, that is delta w is equal to v into dc. Okay, what is v? It is voltage, potential difference. Okay, dc is nothing but I into dt. You take the cross multiplication of I is equal to dc by dt, you will get the dc value is I into dt. So once if you get I into dt, so what we have to do? So the two state between work, that is 1 and 2, what happened? Integration of 1 to 2 into v into I. So what is v into I? That is nothing but a power. So this is about the electric power. Okay, so next one we will discuss stretching of wire. If you take stretching the wire and you are applying force, and what will be the work, that is we are going to find out. So delta w is equal to minus f into, you may ask why they are mentioned minus f, means here the stretching of wire. So we are work is on the system, so work we are giving on the system, so minus f into dl. So where external force is tension and the dl is the change in length. So we know that change in length is nothing but force by the change in length is nothing but extension of the wire. Okay, so whatever the original length will be there, if you, with the help of external force we are stretching and the length will be changed, that is dl. And stress is nothing but force by area. The force by area is also called as, we can calculate by using, that is Young's modulus and strain. If you multiply the Young's modulus and strain, you will get the stress, because Young's modulus is nothing but stress by strain within the elastic limit if you were to consider for the steel. of steel wire. So that is Young's modulus into strain. If you will get the stress also. So where A is the cross sectional area of the wire and E is the modulus of elasticity, or what we can say Young's modulus, and epsilon is the strain. Okay. So the strain is also called calculated by the concept the change in length divided by original length, that is dl by L. You substituting these 2 and 3 equations, 2, 3 and equations, we can get delta W is equal to minus AEL epsilon dt. For finite changes in length, W is equals to A minus AEL integration of 1 to 2 epsilon dt minus AEL divided by 2. What is that? That constant term that we will take it outside. Only variable is strain, that is epsilon square minus epsilon 2 minus epsilon 1. So this is the stretching of the wire. Okay. Next, surface film or work or stretching the liquid in the film. So we already know that the work is done by the wire frame is given by minus sigma S into dA, because sigma, again we are taking the stretching liquid the form, no, so we are considering for the negative work. So minus sigma S, and dA is the change in area, the variable is dA. So for the finite changes, minus integration of 1 to 2 sigma S d into dA. So this is about the surface film work or stretching of the liquid film. Okay. Next, flow work. If you take any of the tank having a inlet and outlet, so with a different datum line, okay, the work is done due to the pushing of entire fluid element across the boundary into the control volume. We can write it as the work flow in and work flow out. So that is the balancing. For unit mass, work flow is P into V. So for this work flow, also we can write it as force into the length, and what is that force is the pressure into area, and area into length is nothing but volume. So work flow we can write it as P into V. So the flow work is also we can write it as P into V. Okay. So next, steering work. Steering work means if you are rotating the object with the help of some force, okay, so that is delta W is equal to T into d theta. So as we discussed, m is the mass of the weight lowered through the distance of dz. So then what we can write it as the d theta T, we can write it as mg dz. So for finite volume variation, we have equation is that mg dz upon integration of 1 to 2. This is how we can write this steering work of the different form. Okay, so I hope you understand the concept of various okay.